Hey everyone, welcome back to lecture. We're sorry about those technical difficulties that we were having on Wednesday. If you went to lecture, not sure what happened, but hopefully it doesn't happen again. And before we begin lecture, I just wanted to remind everyone that Hack Challenge kickoff is on Monday at 8:35 during the usual Android lecture slot. It's going to be after the iOS lecture, so you might see some people in before, which is fine. You can just wait till 8:35. We're expecting you guys to be there, and just take it as a time to get to know other people taking the course and make it easier for you to form teams if you don't know anybody in the course already. So with that, let's begin. We're talking about deployment, but before we get into that, let's go over some review on containerization. So remember that with containerization, we're essentially packaging code into this unit of software that will be able to run on any kind of platform. And we do that by building our code into images by using Docker build. And then we want to run these images in containers. The containers know what needs to be run for the code to work properly from the Docker file that you specify. And you can run the images either using Docker run, or if you made a Docker compose to have a shortcut, you can just do Docker compose up. And then finally, we want to push our images to Docker Hub, and from there we'll be able to save that little unit so that we can pull it from anywhere and be able to run whatever we packaged. So let's talk about servers before getting into deployment. A server is just software near Python app.py, which lets you run the code. And it can also be a hardware device, assuming that hardware was designed to run servers. And it should be able to accept requests made over the network, and it will respond with responses, as we've been doing all semester. Some examples of servers include web servers. You can take Google as an example. We have email servers, which can be Gmail, and then the clients of those servers are the actual web apps that send those requests. And there are also identity servers. You can think of the two-factor authentication you have to do for logging into anything for Cornell. Every server has an IP address, and that's what helps distinguish it from other things with IP servers when connecting to a router. So for example, your IP usually is 0.0.0.0 for your app. That's just the IP that you use to connect to it on your local server. So anything on the LAN network will be able to connect to that. While if you want other people to connect to it, you'd have to use the public IP that you can probably find if you just search up what is my IP on Google. But we need to deploy, and so that's what we need to do to get other people to connect to our server. What users do to connect to a server is using a domain name. So you wouldn't connect to google.com with the IP. You go www.google.com, and then a DNS resolver translates that into the IP address. And let's talk about deployment now. So our app always needs to be running, and it always needs to be receiving requests. And we're able to do that by just leaving our computer on with our app.py running. But the issue is that we can't connect to it. That's what we need now. We need to be able to publicly access it from anywhere on the web. And we also need some hardware that needs to be managed for us and connected to the cloud, which will let us use our Docker images. Reason we need it to be managed for us because we can't just leave our computer running 24/7. It might go to sleep, maybe there's an issue, and so that's why we need to use a cloud service. So we want it to run on the cloud, as said, and that's going to run our containerized software. And the nice thing about the cloud service is that not only does it help us handle the server itself, so we don't need to worry about it going down without us knowing, but it also helps us deal with security, scaling, and crashes. So these are some examples of cloud services. Aptiv uses DigitalOcean, and then there's others like Amazon Web Services, Google Cloud, and Microsoft Azure. You're going to be using the Heroku cloud service during the demo. And to access our server on these cloud services, we need to use the Secure Shell Network Protocol, or SSH for short. And it essentially lets you open, view resources, execute commands, and install packages and update software, just like how you can do on the terminal. You can think of it as, okay, I need to connect to the server, so let me run the SSH command, and then I'll essentially be on a terminal in that server. This is what it looks like. Say if you're trying to SSH into the server that has the Eatery code containerized, you type in SSH-I for the interactive view, which you'll see on the bottom there. It's essentially another terminal within your terminal, and you're in the server. You'll see that we have the directory of Eatery local on our computer, and then here we're at a directory connected to the server. The server.pem is something that holds all your credentials that you need to authenticate with the server for security reasons. And then you'll see here we have appdev. This is the user we're using to connect to the server, which is eatery-backend.cornelappdev.com. Some forms of security for connecting to servers are providing a username, say appdev, and then a password. It'll prompt you with a password, and you need to type that in. There's also public key pairs, where it allows you to authenticate yourself to connect to a remote and vice versa. Say if you want to download a file off of a server to your local. And you can also generate private key pairs to automate login. We'll be using public key pairs which are stored in the PEM. So as I said before, you can just SSH into the user, and then you have your server. You probably want to provide a PEM unless your server has no security, which is not a good idea. And when you try to SSH into it, you'll be prompted with the server key, and you'll be requested when you request to connect. And if you haven't connected before, it will store it into a directory called known hosts, which is going to have all the servers you've tried to connect to in the past. And assuming you provided the public private keys that you need and the necessary credentials, however the server is handling security, if you authenticate it properly, then it'll open the command prompt, as you saw for the Eatery example. So that's essentially all you need to know about how to use servers and how to connect with them. But how would we optimize the way we're using servers right now? So we can do it with something called clustering. Essentially, instead of having one server that runs everything, we can have groups of servers. And as long as you have lots of servers optimized for specific things, it's going to give you a much better overall system. So for example, this is what our server would look like right now. We have one server, which is where we're going to put our cloud, which hosted on the cloud, and we're going to put all of our code in there. And it might have the database stuff in there. Maybe we're doing some file storage stuff, and maybe it's a web app. This is pretty bad because if our server crashes, now we lose access to everything. Well, let's say we allocated 3 servers. One server that's optimized for web application, another optimized for the file storage, and then another one optimized for the database. If one of these goes down, you still have access to the other 2. You can think of how Facebook has crashed. Facebook's Messenger has crashed like for the 2nd time recently. And that was a server that was, well, I mean, we don't know what their servers look like, but we can assume that they had a server for Messenger, and when Messenger went down, it wasn't that Facebook and WhatsApp and Instagram and everything else went down. So they use clustering. So it's for backup and crash handling. That's one of the benefits, as I said. We can also do something called load balancing. And that's also important because, say, for Facebook, again, if we have a lot of people connecting, maybe we have a whole bunch of people accessing, if I go back, maybe there's a whole bunch of people accessing server 1 because they're trying to view the web application. That wouldn't be good because then it would make Facebook very slow. And so the way they would handle that is we have multiple servers for the web app, and then we have a load balancer. So once we get some network traffic, we're going to balance some of that into web app 1, and if that is too filled at the moment, we can move some of it to web app 2 and then web app 3. And then say we have a lot of network traffic, then all we need to do is just add more servers, and then we can distribute the traffic as such. So that's how you'd optimize, and we don't really need to worry about this for our simple apps, but just so you can know. Next week, there is no assignment, and we're just going to be going over authentication, so essentially session token stuff. It is useful to look at these lectures, especially as we're entering Hack Challenge season, because it is nice to have an authentication system for, say, if one of your Hack Challenge ideas is to make social media or anything with login. And I believe you can also learn OAuth if you're interested in how to integrate, say, Google login or Apple login or whatever. We can teach you during this lecture. So thank you for watching, and on to the demo.
Hey y'all, welcome back to Backend lecture. Super sorry that we are having to just do the recording this week. For those of you that came, you know that the projector wasn't working. So here we are in my room. Yeah, I guess we should just get into it. The topic this week is deployment. So, hopefully you've watched the lecture video already and know what's going on. But for those of you that don't, the idea is, hey, how do we get this code that we've written off of our computers and onto servers, onto the internet, onto somewhere that somebody other than me can access it, right? When you're making a backend, like, it's not like the only users of YouTube are the people who made YouTube, right? They want some way for anyone to be able to just type in a URL and access it. So that's what we're going to be talking about today. To this end, we will be using a service called Heroku. Heroku is free, which is very nice. It does have paid tiers, but for this class, you will not need them. And normally, for this class, we use something called Google Cloud, which lets you kind of just take a server, and it's a very raw, bare bones server. It just essentially gives you a computer. So you do what's called SSHing into the server that Google gives you, and all of a sudden you're running a terminal on a remote computer that Google is in control of. And we think that's really good for teaching people, the basic principles of server management. For various reasons, we weren't able to get that for y'all this time because Google Cloud does cost money, and so we would have needed like credits to give all of you. So we're going to be using Heroku this semester, but Heroku, there are some benefits. For one, Heroku takes care of a lot of things for you. You don't have to worry about like how to set up things on a server, right? Heroku will just do it given a Docker image. Two, Heroku's free. So, if you wanted to go on and make projects on your own, you wouldn't have to rely on the credit that we gave you to run Google Cloud. You can just run something on Heroku and it'll work. There are some drawbacks, right? Obviously, because it's a free service, it's missing some things you might want. And, they're trying to optimize their own compute. So, for example, Heroku will kind of clear data every 24 hours. So if you're storing any files on a Heroku server, other than the image for your code and stuff, those will be wiped every day. I believe every day at the minimum they'll be wiped. It might be more often than that, depending on how often they kind of scrape through their servers and stuff. Which makes Heroku very unfriendly with SQLite, because SQLite is a very small flavor of SQL that likes storing things as files. So it's a little unfortunate, but just keep in mind that when you're doing the hack challenge, every 24 hours, your data is going to be wiped if you're using SQLite. And so please, if you do need any pre-coded values in your database, make sure that you kind of refresh those values as necessary. We'll try and let y'all know when we grade so that you can kind of put them in, but you know how it is. What we kind of recommend doing in that case is actually loading things in from things built into your image, just making sure that they're perpetually there. But just a problem to keep in mind. Anyways, with that, let's get into how to set up Heroku, right? So what we have is this Heroku website. You're going to have to sign up, right? So you can click on sign up and it'll ask you for all of this information. I've already done this. You can go through it. For a company name, you can do whatever you want. It's like not necessary. Role, probably student, all that jazz. None of these questions super matter. It's really just for their own kind of data gathering purposes. Anyways, let's log in. And now I'm in the Heroku dashboard, right? I don't have any app set up yet, so it's saying I could create a new one by just clicking on that. We will actually be using the terminal for this. So what I would actually recommend you do is kind of, here, let me Google Heroku CLI. And you just click on the first link. And all of a sudden, it'll give you instructions on how to install the Heroku CLI. There's Mac, there's Windows, there's Ubuntu. There is a Windows installer. But Heroku does depend on Docker. I have had some people get the Windows installation to work. So, you know, if you're really sick of using the VM and you're on Windows, I'd recommend giving it a shot. But I think there's a solid chance what you're going to end up having to do is go onto your virtual machine and use the Ubuntu instructions. For what it's worth, if any of you happen to be using WSL with Docker, which, impressive, you managed to set that up, because WSL, you have to do some finagling and upgrade to WSL2 to get it to work with Docker. But for those of you that know what I'm talking about, if you're using WSL2 for this course, you'll have to figure out a different way to get it, because Snap doesn't work with WSL at the moment, I believe. In any case, install the Heroku CLI, and then you should be good to go. Cool. So, now let's go to my terminal. You're going to have to do some things. You're going to have to run docker login. I hope that that's not how to spell Docker, because like I mentioned, Heroku kind of relies on the fact that your Docker works. Praying that okay. Weird. Well, succeeded. So you're going to have to run Heroku login. And it's going to ask you to, hit a key, and then it'll open up the browser, right? So let's come back here. Log in. Cool, because I already logged in another tab. Let's go back to the terminal, and so that's perfect. And that instruction, by the way, just came from the Heroku CLI. Cool. So next steps. So we've logged into Heroku, but remember, we're using Docker to store our images, and we're going to need some way for Heroku to know how to run that image. Heroku has a solution for us. They have what's called a container registry. So a container registry is something that stores and runs containers for you. You'll need to register your container with their container registry. So kind of like Docker Hub or DigitalOcean has their own solution, etc., etc. But to log into that, we're going to write Heroku container login. That's fine. I haven't updated Heroku in a bit. Cool. Now what we have to do is we have to create our Heroku app. So, I have a feeling you guys can't see that terminal window. Let's do this. Now I think it should be good. Heroku create, and then you'll have to name it something, right? So I'm going to name mine RM834 demo. You're going to want this to be unique. And you'll see why in a second, but let me just type this. Perfect. And you can see that it gave us our URL, right? Remember, when we type this in, it's going to use the domain name system to map it to an IP address and then access it, right? Luckily, the Heroku app domain is already registered, so they can easily register their own subdomains, in this case, RM834 demo. Now, what if you didn't create something unique? Right? So I use my net ID in there to make it unique, but what if I did like Heroku create foo, right? That's probably thinking. Yep, name foo is already taken, so it won't let you. You have to make sure you name your thing unique. Similar to, website names would have to be unique. All right, what else? Cool. So now let's go to the browser and see what happened in our dashboard. Is this one? There we go. Refresh the page probably. There we go. Now we can see that our app showed up. So if I click on that, oh hey, we can open it. Perfect, let's try that. Welcome to your new app, refer to the documentation. That page is missing. Well, why is that? All we did is create it. We didn't actually put our code onto it or anything, right? So let's go and do that. We will have to make some edits to our code first. So I'm going to have to open the code in Visual Studio. Oh, no, don't look at my number theory stuff. Oops. Perfect. So now, 1 second. What is my hotkey for code change? Give me a second. There we go. Got the code to show up. That probably looked really weird. In any case, we're going to have to make a couple of changes here. For one, if you haven't already, you're going to need to add import OS to the top of your app.py. Right? Next, here, let me make this bigger. In your if name equals main, we're going to run port equals os.environ.get port, comma 5000. Now, why is this? Well, if you remember when we were creating our Docker files and compose files and stuff from last time, we exposed port 5000, right? And that's because we knew it was going to run on port 5000 on our machines. Heroku might be using port 5000, right? If everybody tried doing port 5000, all of a sudden, for every kind of computer Heroku was running our code on, they would only be able to run one thing, because everybody wants port 5000, right? So what Heroku does is instead, it maps whatever port you want to one of its own ports. And we need to figure out what that port is. Luckily, Heroku gives that to us, so they store it in an environment variable just called port. So os.environ returns a dictionary of environment variables. In this case, we want port, so we're just getting port, and as long as it has a value, getting that. Remember that you can set default values with os.environ.get, so in this case we're doing 5000. If we want to run this locally, this way port will be 5000. And so now we just say port equals port. I believe that is the only change that I had to make to this code. So if we go back into the terminal, I think I can run, sorry, no, there was one more thing I had to do. Let me go back to that. We don't want to be running debug anymore. This is because we will be deploying to a production environment. And now you may say, hey, but don't we want it to still have debug things? It might be nice, but we can have our own logging elsewhere, and debug equals true is a major slowdown on a server, because it has to all of a sudden output a lot more things, keep track of a lot more things, and we don't want that on a production environment. We want anything that's user-facing to be as optimized and fast as possible. Debug is really just for local development, so let's just get rid of that. Okay, and that should be good. So now if I go back to the terminal, we can run Heroku container push web at rm834 demo. And so just keep in mind when you run this command, it's going to be container and we're pushing. We have to specify we're pushing to a web app, which is really what our server is, and then the name of our app, which is rm834 demo. And then what it's going to be doing is it's going to build from our Docker file, right? So it built everything and now it's pushing and hopefully it works. Pushed, perfect. Oh, still more. This pushing isn't the only thing we're going to have to do. Just having it on the server doesn't tell the server to run it. So what we're going to have to do after this is we have to do what's called releasing the code, and that's going to be another Heroku command, Heroku container release instead of container push. Once it finishes, let's try. It's almost done. There we go. Perfect. You can release it with the Heroku container release command. So now let's run that. Heroku container release web app rm834 demo. Released. Let's check out if it works. Let's go into the browser. And now, when we try opening the app, application error. What did I do? That means we had an error, for what it's worth. So let's run that command. App rm834 demo. Key error, secret key. Secret key equals os.environ, secret key. Ah, I see the problem here. We have some leftover code from the last demo. So let's fix that. Let's see if we're using the secret key anywhere else. Def hello world, and I'm just going to have it return hello. Okay. Now let's try it. So if we try Heroku container push, should probably test it locally to make sure it works. We'll see. That error, by the way, happened because because we hadn't set up Heroku to work with our environment variables, right? So there are ways to do that. I would recommend looking into the Heroku documentation to see how it works. For now, we're just covering how to release things to Heroku. Heroku container release. All right, released. Now let's try it again. Refresh. Cool. So now you notice it's taking a while to kind of, perfect, return hello. Heroku has something called a cold start. And that's because, you know, for a lot of Heroku apps, a lot of users will like run their server, and then maybe they'll never come back to it. Maybe they'll come back to it once a week, right? Heroku doesn't want to be wasting their own compute on people whose apps aren't really being used that often. They want to give it when it's used. So if your app isn't running for, I believe, half an hour, Heroku will turn off your server. Right? And you might be like, oh God, they're turning off my server. That's terrible. Well, like, yes, but also, as soon as there's any incoming traffic to your server, Heroku will turn your server back on. The only problem is turning a server back on is much slower than just keeping a server on and hitting it. So you will incur a cold start delay for this. And it's, you know, it depends. It's like anywhere between 15 and 30 seconds usually. So just something to keep in mind. If it's taking a while to load the page, that's just how it be. But yeah, so we can see that it's working, and that's how you get things onto Heroku. You could use this URL to test things in Postman here. If I do say, oh, that's not what I want to do. Slash tasks. Perfect. If I try getting one, it'll give me a error for task not found. So perfect. Everything should be in working order. Now what I actually want to show all of y'all is SSHing into an actual server. So here you can see that I have a file called transitserver.pem. This is a file containing our private key pair to access the transit server. So I'll show you guys what it would look like if you were more like using Google Cloud. I believe we got this server from DigitalOcean, but don't quote me on that. So for one, if I just try SSHing into transitbackend.cornellapdev.edu, right? Could not resolve hostname, right? I think that's, yeah. Oh no, it's .com, my bad. permission denied public key, right? So what I have to do is I have to write ssh.i transit server.pem. But we might run into another problem. Permission denied, public key. Notice it added root here. This is because it's trying to figure out who's trying to access this, right? When I just ran SSH normally, it added Rocky. Here, when I ran sudo, it added root, right? So what comes before the @ sign is the username that you want to log into. Now, I don't believe Rahi exists on this server, so if I run transit server.pem transit backend.com. So if I run ssh-i transit server.pem, oh, that's a sneak peek of what's to come. And then I just run transit backend.cornellappdev.edu. Could not resolve hostname. I did it again. Con. That's fine. Give me permission denied. This is just saying that I need to mess with my PM read-write permissions, which, like, I should, but this is my own computer, it's fine. Here, I'm going to get permission denied, because Rahi doesn't exist. Now let's try this again. If I write appdev here, and also, it'll work. Perfect. So now we can show you what the transit server looks like. If I go into our Docker Compose folder, we have our docker compose.yaml, so let me show you that. And you can see transit actually has multiple images running on it, right? It has our transit node, it has our Python microservice, it has how we actually map things and route things, it has walking directions, right? It has all of these things in this one server. And transit has another server just to handle routing, right? So you can see how you might have a lot of images running together. In this case, what we would have to do is we would have to run docker stack deploy using our compose file, just because of how we've set things up on transit. But it's a very similar idea to docker compose up, which is how I actually test transit locally. I just run docker compose up. Cool. Well, that pretty much ends the demo. I hope y'all enjoyed, and I hope it was helpful. Good luck on the hack challenge.